Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to technical session 9D. Myself, Priyanshi Goyal, and this session would be moderated by me. I, on behalf of Global Knowledge Research Foundation and GR Scholastic LLP, welcome you all to the 9th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2025, Pune, India. The 9th edition of the conference is being organized in a hybrid mode. The physical event was held day before yesterday in Pune, India, and the virtual event is being held through Zoom yesterday and today, that is 30th and 31st of January 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have trend presentations. Each presenter will be given 8 minutes for the presentation and 2 minutes for question and answers. On 7 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Dr. Lokendra Singh Umrao. Dr. Lokendra Singh Umrao is an associate professor, Department of Computer Science and Engineering, Madan Mohan Malviya University and Technology, Gorakhpur, India. With over 11 years of teaching experience, his specialization lies in algorithms and high-performance computing. His research interests include blockchain technology, Internet of Things, big data analytics, and parallel computing, contributing significantly to advancement in these domains. Thank you so much, sir, for joining us. I had now like to invite Dr. Lokendra to share a few words of encouragement with our attendees as we begin this session. Sir? I think there's a technical glitch. Hello, sir. Yes, sir.
Thank you very much for inviting me as a session chair for the 9th International Conference on SMARTCOM. So this type of conferences always sharing the knowledge between the authors and researchers. So you can gain the knowledge and implement in the near future to increase the research in the field of computer science and engineering in their own institutions. And these experiences will always help to the countries also. So welcome all the participants. So we will suggest some review also after the ending of the each sessions. Thank you. Thank you very much.
Thank you so much, sir. Now, without further ado, let's start with the session for today. First up, I would like to request Sakshi Limkar to kindly present her paper titled AI-powered chatbot for mental health assistance. Do we have you here with us, Sakshi?
Yes, ma'am.
Hello?
Yes, ma'am.
You're not clearly audible?
I'm audible, ma'am.
Yeah, slightly better. I'll stop presenting so that you can share your screen.
Okay, ma'am, surely.
I also kindly request before we start to all the participants, please adhere to the time limit and try not to exceed it.
Okay.
You may start now, Sakshi.
Yes, ma'am. Ma'am, is my screen visible?
Yes, your screen is visible.
Okay. So, the presentation topic for today's conference is AI-powered chatbot for mental health assistance. My paper ID is 515. Dr. Aarti Bang, our professor, have helped us to guide throughout the program. So my partner Chandavi Govardhan Devani Dahake are there. So this is the outline for my presentation. So introduction, why we chose this project or why we have tried to research on this is the mental health is an worldwide issue which we are going through in Delhi. it is a big stigma which we face daily. Mental health issues affects millions of worldwide, and access to care is often limited due to stigma, cost, and availability. So AI-powered chatbots provide an accessible and affordable solution by offering real-time support using natural language processing. Our chatbot, developed using Dialogflow, aims to increase engagement, reduce stress, and support overall mental being. In today's world, many of the peoples are facing through mental health issues and are afraid that someone will judge them on this. So we have tried to build a mental health chatbot which will be a cure for them. So we have referred many of the research paper published worldwide, and we have come to an uh, uh, research that NLP is the best solution to be provided for the mental health assistance. So we have used NLP as a best tool for our project. So objectives of this project was to provide accessible support, which is the 24/7 support for the mental health assistance, which reduces stigma and users and encourage the users to seek help without fear for judgment. Enhance user engagement. So we have developed tools like which can help them to cure their anxiety, stress, or any thoughts which they are facing through day-to-day life, which will reduce their fear and will engage them to any or other exercise like games or breathing exercise, which will reduce their thoughts. Real-time support is offered by the system, which can be operated in any time, any day, at any moment, and it encourages self-reflection. So we can think on our mental health and can reflect or overcome the mental health issues and be uh, a healthier person in the state of emotions. So motivation was to provide an mental health chatbot which concerns all the issues. Mainly we have focused on 4 issues, that is anxiety, depression, or stress, and suicidal thoughts, which is a global concern. In day life, we have faced many suicides in many of the students growing in day-to-day life. So this was our main motivation. By taking this, we have developed a chatbot and a website interface which have the capabilities of finding out whether one person is going through stress or anxiety, which he can communicate with the chatbot and can seek help for the this. We have used AI, NLP, and these these tools for the support. So this is the block diagram of the project. So how actually it works. So first it is the user input, and chatbot is frame which takes a user input. So if we say chatbot that I am feeling overwhelmed lately, so it will process the input which the dialog flow processes. It is in NLP processing process, natural language processing. So it will process and he will tell you that you are suffering from anxiety. So he will classify the text as an thoughts. So it will identify the mental condition. That data will store with the person's name with the database in MySQL. Or if we want to retrieve the data, what I have done or what anxiety issues I was facing and when I was trying to find out. So the user can ask the chatbot, I want to track my data. So if we say yes, so it will retrieve the data from the database and the system will work. And if he says he want any exercise or any help, the chatbot will redirect him to the website, which is an web interface, which have many of the breathing exercise in different games. So this is the methodology which has been used. So first is requirement and analysis, identify user needs. So user needs is identified. It addresses real-time and mental health support. The chatbot is designed to detect common mental health conditions such as anxiety, depression, and stress and suicide. As told by me before, that it only engages with these 5 things only, which are depression, stress, suicidal thoughts, and normal nerves. As we have given the chatbot input of 75 to 80 characters, sentences which were taken from different sites and websites and social media. So it has developed in a way that it detects these 5 of the things, and the backend for it is the chatbot development dialog flow. It is an machine learning and tool which is pre-developed tool for natural language processing. It uses different types of text classification tokens and methods. Backend is Python and fast API to connect the dialog flow to the database to for the secure connections. And the database management which I use is MySQL. So hardware requirements are these that your laptop must be Intel 5 or higher generation laptop. RAM minimum of 8 GB. Storage at least 256 GB SSD and stable and reliable internet connection is there. And these are the peripherals that dual screen setups and mouse are required. The software requirement is operating system. Windows is required. IDE which we have used is VS Code, or you can also use a PyCharm as an IDE. Languages which we have used is SQL, Python 3.8 and higher. Framework, fast API, we want to connect the dialog flow with the database. And database is MySQL 8.0 or higher. So backend dependencies, these are the dependencies which have to be installed in the laptop for getting engaged with the dialog flow.
This is a 7 minutes reminder.
Okay. So this is how the chatbot works. So if we give an chatbot these inputs, hey, and if we say I am feeling overwhelmed lately, so it seems to be are feeling anxious. So do you want any help? Then it gives, we can encourage us to try the listen to our website or go on to the website. So if you want to track your diagnosis, so you can retrieve it from just getting track my diagnosis, what was the name, and he will say it was normal when you check it. So application in personal health monitoring, support for mental health consulting, corporate employee well-being programs can be their education sector and suicide prevention and crisis management. Conclusion that it enhances mental health support, provides 24/7 well-being, encourage self-care, that it help us to interact with our mental health, and one can be interacting with any non-judgmental support. It bridges the gap between users and professional mental health services. Advanced scope that it can be incorporated in wearable devices like watches, or it can have multilingual support which can help it in many languages, or it can be without any language restrictions, or AI driven therapies can be incited in it. So this was how the research paper was being done, the references which we have taken for the developing the chatbot. Thank you.
Thank you, Sakshi. Are there any questions? Are there any questions?
Sakshi,
Yes, sir.
how can you define the reliability in the internet connections?
Reliability in interconnection, it should be strong, sir. Actually, it has to be at least support minimum range. Like 5G can be encrypted, 3G, 4G, or 5G can be used for the chatbot. It can be work below that.
Okay.
Thank you, sir. Moving forward, I request Akshar Thakur to kindly present his paper titled Contemporary Cryptography Against Quantum Computing and LBC on Embedded Systems. Do we have you here with us, Akshar?
Yes, ma'am. I'm here.
Okay, I'll stop presenting so that you can share your screen.
Okay. So I hope everyone is able to see my screen.
Yes, it's visible.
I'll start the presentation now.
It's not available in full screen. Akshar, can you just...
I'll.
Put it in slideshow.
Okay. Can you see it?
Yes, now it's visible. You may start.
Okay. Just give me a second. Is it visible?
Yes, it's visible. You may start.
Okay. First, I'll start by giving a brief intro. So, respected Chair, I would like to begin by giving a brief intro to the paper. Our paper titled Contemporary Cryptography Against Quantum Computing and LBCM Embedded Systems is intended for scholars looking to begin research work in the field of novel cryptography. Authored by me and my peers, named so on the screen, and guided by our two mentors from my university. It is presented at SMARTCOM 2025 conference, paper ID 543. So, the importance of data in today's age need not be pressed more, as it is prevalent and it is everywhere, and it is generated and stored and by interactions such as personal interactions, your professional engagements, your social media activity, and generated by IoT and peripheral devices. It is created by everyone at every moment of their being, and the security of data is a very important thing to take into consideration in today's day and age. Now you must be familiar with the current cryptographic algorithms such as the RSA and defilement facilitated AES. These two are facilitated by problems such as large integer factorization and discrete logarithmic problem. And this particular property is utilized by ECC as well. And the hardness of these problems that make them strong against current supercomputers are the very same properties that make them weak against the quantum computers. Quantum computers using quantum algorithms such as Shor's algorithm makes these Achilles heel for the cryptography, because they are solvable in real-time complexities by quantum computer using algorithms such as Shor's algorithm. So we propose LBC as an alternative, and going forward, LBC is a potential candidate for the post-quantum world cryptography, because LBC has certain properties that falls in line with the security on the platforms of both supercomputers and against platforms using quantum computing. Our paper goes our paper goes on introducing us with the vulnerability of current cryptography first, and then realizing the threat that one day quantum computing can become. We should start looking for cryptography measures that are not only secure against traditional computing but also against the new approaches of quantum computing. In a large view context, two domains we should focus on are cryptography methods and key exchange methods. After briefing on this matter, the document will go on focusing on one of the cryptography methods that has the potential of being a lucrative candidate in the domain of quantum resistant cryptography. Now, lattice-based cryptography, LBC for short, is essentially a cryptography method that is harder to break by both classical and quantum computing methods. It uses vector space and linear algebra to perform encryption and decryption. Without going into much detail of it, we can understand it as encryption done in the vector space by storing data as points in the vector space, using two vectors, and decrypting the data using the same set of vectors. The vector space, however, can be created by many such pairs of vectors, and without the right pair and in larger dimension, finding the correct data point becomes infeasible even for quantum computers. Some advantages and some disadvantages listed here. Less resource demanding because it uses linear algebra and low learning curve. It requires uh, knowledge of linear algebra as well as some basic knowledge of cryptography to learn, and the main benefit being the quantum resistance. But there are cons too, like the parameter of keys that need to be decided, because after a certain amount of dimensionality, generating and operating on such key and vector spaces becomes hard. And the application scale, like the underlying hardware that we will be using and such, we have to consider before applying the method. However, the LBC is not only single method applicable to quantum resistant cryptography. There are other methods which are listed. The table is from our paper and which are listed here, and they include techniques such as signature based hash, signature encryption has code based and multivariate based signature encryption, and finally the LBC. All of the properties of which are listed in this table. And then there are LBC. Why LBC? Why we've chosen LBC as the potential candidate for the post quantum cryptography is because, as everyone can understand, the IoT and embedded devices are only going to skyrocket in the future, and they are everywhere. We can find them everywhere around us, starting from the very smartwatches that we wear to health monitoring devices to the thermostats that we have. IoT and embedded devices are everywhere, and these devices often gather data that are sensitive and should be protected. And that is why implementing the cryptography methods on it, which is future ready, is essential. The IoT devices have characteristics such as wireless connectivity. They collect data and they have low computational capability, which makes it suitable for applying LBC because it falls in line with what LBC promises. The potential has secured a quantum proof world and IoT embedded electronic peripheral devices, and previous studies has been done on it to show that very constrained devices such as
The 7 minutes reminder.
ARM Cortex M4 processors, which have RAM of 192 KB and an MB in flash to run such algorithms. So it is possible to run such algorithms on very constrained spaces. Future of LBC holds answering us questions like how to implement them in extremely constrained environments so that the prototyping can be done on devices such as Arduino boards, and which have very limited resources, falling in line of 2 KB RAM and such. And another questions are integrating with existing measures of existing cryptography methods and getting the best of both worlds. And one more field of research can be standardization of techniques like 5G and 6G communications. In conclusion, I would like to say that it is not as LBC is not only suitable for industry but for academia and developers too. It synergizes with current trends of the digital world of growing IoT and embedded devices, and it has the potential of leading the post-quantum cryptographic revolution. Thank you.
Thank you, Akshay. Are there any questions?
Achal,
Yes.
There is a formula on quantum physics. E is equal to
Okay.
h nu.
E equals to h nu. Yeah.
You hear or not?
Yes, I've heard of that.
So we know the quantum computing works on reversible engineering.
Excuse me, can you repeat?
Quantum computing works on reversible engineering.
We can think of it in that way.
Oh, okay.
Okay.
Thank you, Akshay.
Thank you.
Yes. Next up, I would like to call Nitin Pandit to kindly present his paper titled Cyber Attack Network Investigation System using ML. Do we have you here with us, Nitin?
Yes, ma'am, I am here.
Right. I've stopped sharing so that you can present your screen.
Okay, ma'am, okay. Ma'am, is it visible?
Yes, it's visible.
Okay. Myself, Nitin Pandit, I am pursuing a BTech in Pune. My project name is Cyber Network Investigation using ML. There are some outlines like introduction. We have put in this PPT. First one is introduction. So a denial of service DOS is a malicious attempt to disrupt the normal traffic of a targeted service or network by overwhelming it with a flood of network traffic. In this context of network, DOS attack poses significant challenge as they can result in service disruptions, loss of revenue, or damaged reputations. To effectively combat these attacks, modern systems are increasingly integrating machine learning techniques like by using cyber attack network investigation system which leverage ML algorithm. It becomes possible to identify unusual patterns that may indicate a DOS attack in real time. So the next one is motivation. The motivation behind developing cyber attack and network investigation using ML specifically for detecting denial of service stems from the increasing and frequency of cyber threats in today's internet world. The need to protect such sensitive information, ensure availability, and minimizing downtime is more critical than ever. So the rising first is a rising frequency and of rising frequency of DOS attack. Traditional security systems such as firewalls and intrusion detection systems struggles to detect modern DOS attack due to complexity and ability to evolve. Attackers are continuously developing new techniques, making manual detection method less effective. Machine learning offers a way to stay one step ahead by analyzing vast amount of network data and detecting emerging threats faster and more accurately. To protect computer systems, it is more important to consider the concept of CI, confidentiality, integrity, and availability. So there are some issues which can create DOS attacks in today's life. So first is data quality and availability. ML model requires large, high quality data sets to train effectively in cybersecurity. Collecting relevant and clean data can be difficult due to privacy concerns, lack of labeled data, or the complexity of real-world environments. Second one is imbalanced data, like challenges. So there are some challenges in imbalanced data, like especially with the rare types like advanced persistent threats or zero-day attacks. The data set is highly imbalanced with far more than normal data than attack data. So next is adversarial attacks on ML models. Challenges attackers can intentionally manipulate inputs to deceive machine learning models. This is known as adversarial attack. So impact is it undermines the reliability of the ML based models and make it vulnerable to manipulating by attackers. So this is the literature survey that we have put in this PPT. First one is happening in 2022. The second one is in 2021, and the third one is in 2019. So the main problem statement is how can a scalable real-time and adaptive system be developed to detect and prevent denial of distribution attacks across heterogeneous environment and network while minimizing false positive rate. So some objectives and scopes are there. First one is create an application we can perform attack. In our project, we have create an application, or maybe we can also create a site. In this site, we have suppose a user wants to access a location, access a website to download some stuff, So for this, the attackers use multiple requests to break the server and to put down the server so that the main information of this website can be steal. Next one is create a code where a real-time attack was done. For this, we have created in our project, like we have created a code. So in this code, when multiple requests can happen in website, it automatically detects and reject the IP address, and it can prevent our information data. So next is a scope. So scopes are like network traffic analysis. Like if network traffics are sometimes gets higher, so the websites are getting down. So for this, we have prevented in this our project. Next is real-time detection. So ML model can also identify unusual behavior from the IP addresses, and it automatically starts blocking the IP addresses. So we have also proposed a system architecture in this user. If suppose there are two types, one is attacker, and the second one is a user, a normal user who wants to access the information. So in this, clients are requesting user for the FDM for some data, and FDM FDM can go to this server. And next attacker also requests multiple users to the server, in machine learning there are some algorithms that we have put in our project so that it can prevent it. Next is a use case diagram. So in use case diagram, as you can see that there is a user I have created in my project like a registration. First, the user have to register for the website to log in for accessing some information or some files. So for this, they have to register first, log in, and also when they log in, there is a OTP which is going to his email ID so that he can access the information. So maybe it looks like a valid, it is user. It is. So this is the use case diagram for this. The next one is mean shift algorithm. Mean shift algorithm is simple. We have used in our project. What
This
is
is a
algorithm
7 minutes
do?
reminder.
Yes, ma'am. In this, if first it starts, it initialize all client and server configuration. Like it can verify user that authorize the user that it is the real user or not. It enlist and display all clients on server. It display all clients among themselves, initializing, sending and receiving scenarios between server and observer. So next is validating invalid requests, like if the user are either invalid or not authorized, and they can create some multiples things which can put down in website, so it can directly block the user IP addresses. So the advantages is prevent a server from crashing, block illegal users, legitimate user can user online services without any interruption. So the conclusion is network attacks can be costly and frustrating and are difficult, if not possible to destroy. The best defense is to handle attacks through vigilant system administration. Future scope is anomaly detection using AI. Machine learning models, especially deep learning, will continue to evolve to detect subtle anomalies in network traffic, indicate of DOS attack. Adaptive models, AI system that adapts to new patterns of DOS using unsupervised or reinforcement learning. So these are the, yes ma'am. Yes ma'am,
You
done,
have,
done, done.
yeah.
Yes ma'am, done, done. This is the references. Thank you.
Thank you, Nitin.
Yes.
Are there any
Nitin,
questions?
you know
Yes,
the
sir.
CIA in cybersecurity.
CI, yes, sir.
Huh.
Sir,
What is
CI,
CIA?
sir, CI first C means confidentially. It
Huh.
ensures information is only accessible to those who are authorized to view it. This protects sensitive data from unauthorized access. Next one is integrity. So it ensures the data is accurate, complete, and reliable, and that has not been tampered with during storage or transmission. So the next one is availability. So it ensures data, system, and resources are available when needed by authorized users. So yeah, sir,
Yeah.
that's it.
Okay.
Yes. Thank you, sir.
Thank you, Nathan. Moving forward, I would like to invite Kavita Mohalkar to kindly present her paper titled Differentiating Between AI-Generated Faces and Human Faces. Do we have you here with us, ma'am?
Yes, ma'am.
Sure. I've stopped sharing the screen. You can please present yours.
Sure. I hope my screen is visible.
Yes, your screen is visible. You may start.
Yeah, thank you. So good afternoon, everyone. Today I'll be presenting papers of my student that is differentiating between AI generated faces and human faces. This paper basically speaks about deep fake technology. So let me first introduce what's a deep fake. It is a type of a systematic media where we can use AI and deep learning techniques which can generate images which looks like realistic images. I hope I'm audible. Hello.
Yes, ma'am, you're audible.
Yeah. So this deepfake has had a long run nowadays when generative AI has came into existence. Now this deepfake is a combination of deep learning and fake images which have been now circulating all over. This motivation, that's the security reasons, the digital forensics and content moderation are the major threats which these deepfake images have now given. So the objective of this paper is to build a robust hybrid model which will combine the vision transformers and exception net to accurately distinguish between real and AI generated faces. So we are trying to detect a model which will adapt to the evolving GAN techniques where the artifacts are very minimal and the synthetic images are appearing to be normal. So we need to identify the difference and make according the changes. For the literature survey, few papers were surveyed where we found that different techniques were available for classifying deep fake images, out of which SVM classifier, convolutional neural network, long short-term memory, exception net using LRP and LIME techniques, along with VGG face architectures or identity consistent transformer techniques were used till date. They used variety of data sets like ImageNet dataset, Face Forensic Plus datasets from Flickr, and other datasets also. The accuracy what they tried to achieve ranged from approximately 80% to 92% on an average. Only in some cases where a Kaggle dataset using Flickr and StyleGAN was used, they said the dataset accuracy went up to 99.7%, where they had a problem of overfitting. So we wish so the challenges with the existing system were when we use a CNN based model, they focus on only localized artifacts where they have inconsistencies at pixel level. They fail to capture the global relationships between the images and hence are very less effective when you have a high quality deep fake image. Second challenge is the handcrafted features. Early methods were all depending on the handcrafted features where we identified landmarks and texture patterns. Whereas the ineffectiveness of the high resolution GAN generated faces is due to the fewer visible artifacts which are available. The advanced GAN techniques like StyleGAN and ProGAN reduce the pixel inconsistencies and hence making the traditional methods unreliable. Hence, the main objective of the complete project was to find a solution which combines the global structure and the local structural analysis to improve the detection accuracy. We propose a hybrid model which will combine the vision transformers and exception net in soft voting ensemble framework. Now, VIT, which is the vision transformer, is a deep learning model which is designed for image recognition tasks, which, unlike the convolutional models, it applies transformer-based architectures to all the images. It captures the global spatial patterns and long-range dependencies. Second one model that we are combining is the exceptional net, which excels in detecting the localized textures and inconsistencies in the model. We are taking a data set of about 1,88,800 images, where we have 94,400 real images from Celeb A dataset and 94,400 synthetic images which were generated using StyleGAN. Pre-processing steps involve resizing of the complete images to a standard of 256 by 256 pixels for a uniform output. The grayscale conversion was done. Data augmentation techniques like random rotation, scaling, and horizontal flips were used and to increase the robustness and reduce the overfitting of the dataset. We took almost the training set of 1,40,000 images, where we had 50% real and 50% synthetic images. The validation set had 38,000 images with 50-50 percentage of real and synthetic data, and testing images was 10,800, again with 50-50 data. Combining vision transformers were the main input to the transformer architecture. The vision-based transformer uses a self-attention for global relations and has a better performance than the CNN part. In this project, VIT is used to detect the spatial inconsistencies in the AI-generated faces, where we have asymmetry and unrealistic spacing between the features. The key parameters of VIT transformers including that is the transformer network. We are using a pixel patch size of 16 by 16 pixel. Here we are using transfer learning and fine tuning. So a pre-trained network model has been used on ImageNet and fine tuned on the available data set which we are using. The VIT transformer captures the global spatial patterns and long-term dependencies, and it enhances the anomalies in the image. Why exception net is combined? Whereas exception net is again based on CNN, but it uses depth-wise separable convolutions. It helps us to identify the local anomalies and excels in detecting the subtle textures available and the inconsistencies which are available with the GAN, where GAN fails to replicate it. The GAN, if we just use GAN, the generated faces, the unnatural smoothness in the skin texture or irregular transition of the light makes a problem. In exception net, we are using an efficient net V0, which used for feature extraction. And then we have optimized the image size in
7 minutes reminder.
Yeah, 128 by 28 for efficient computation using Adam optimizer with cross entropy. The ensemble method combines both of the features, both the transformer models to get an output which will has a feature fusion, then weighted averaging which will balance the contribution of both the models, and the final classification is there for the softmax layer is being used. The strength includes capturing the local as well as the global spatial relationship using the proposed model. The model achieves an accuracy of 92.3%, test accuracy, and 91.8% of recall, 92.5% precision, and an F score of 0.922. Comparing with the existing models like ResNet 50, Inception V3, Standalone VIT, Standalone Exception Net, we have achieved a better performance without overfitting of that model. So to conclude, the hybrid model is more effective as it combines VIT and exceptional net models for accurate detection of AI-based features. Applications include challenges posed by GAN and style GAN, like digital forensic, content moderation, fraud prevention, and also in biometric authentication systems. And in future, we can focus more on other parts like improving the generalization through alternative transformer-based models We can adopt new GAN techniques and enhance the feature engineering for increased model robustness. Thank you.
Thank you, Kavita ma'am. Are
Thank
there
you,
any
ma'am.
questions?
Any
Are there
questions?
Right, since there are no more questions, we'll be moving forward.
Thank you, ma'am.
Thank you, ma'am. Next up, I'd like to invite Ma'am Rupali to kindly present her paper titled Enhancing Event Classification Accuracy and Reliability Through Red Panda Optimized Feature Integration in Predictive Systems. Do we have you here with us, ma'am?
Yes, ma'am.
I'll stop presenting so that you can share yours.
Is my screen is visible, ma'am? Hello, am I
No,
audible?
ma'am. Yes, ma'am, you're audible. Your screen is not visible.
Just a minute. Now it is visible, ma'am?
Yes, it's visible.
Okay, thank you. Good afternoon, everyone. My paper ID is 615. Today I am going to present the paper titled Enhancing Event Classification Accuracy and Reliability through Red Panda Optimized Feature Integration in Predictive System. So these are the outlines of today's presentation. Introduction. See, for efficient real-time decision-making in variety of domains like cybersecurity, finance, industrial IoT, or Internet of Things, accurate and trustworthy event categorization is very important. So by maximizing this feature integration, so this paper explores how incorporating the Red Panda, a real-time data streaming platform, into predictive systems. So predictive algorithm might improve the event categorization. Here in the continuous, when we want the when we have the massive amount of data, how the continuous or high throughput data is processed. So it is possible with the help of Red Panda. So Red Panda is basically the useful for the low latency and fault tolerant architecture. So which enables the real time extraction of variety of accurate attributes. So predictive models may use the Red Panda's capability to access current and augmented feature sets, which will greatly increase the classification accuracy and dependability. The variety of models gives the accuracy and system robustness. The benefit of the real-time data streaming in the predictive analytics are demonstrated using the results, which I'll show you. So Red Panda is basically for the fault tolerant, high performance and real-time data streaming platform, so that can manage the large or massive amount of data with a little delay. So Red Panda is basically well suited for the predictive systems where the optimizations of the real-time data processing are essential for enhancing the event categorization, accuracy, and dependability. So Red Panda is real-time data intake and processing capabilities are among most important advantage. So Red Panda makes it possible for the predictive system to make the judgment instantly by handling the massive amount of data. So it guarantees that the characteristics obtained from the real-time streams are always current. So this is the literature review. So by linking the physical objects, sensors, and machines extensively to digital networks, the industrial IoT has completely changed the industrial processes because the lot of sensors are connected to get the results and outcome fast. So this significant advantage of these interconnections include the improve operating efficiency, predictive maintenance in the real-time monitoring. So it definitely helpful for the industrial IoT to get the advantage for the industrial IoT. So, but the industrial IoT ecosystem always brings with the new security risk. So that risk are predicted with the help of this Red Pandas techniques. So according to the Liu and other authors, it is more important. So IDS is more practical for the industrial IoT devices with the limited resources, because optimal feature selections gives you the better performance. So additionally, other authors also shows that in industrial IoT network with the constrained computing resources, the use of support vector machine in the conjunctions with the feature optimization strategy is greatly helpful for improving the accuracy. The use of deep learning models and other feature engineering concept in order to improve the detections with the both known and unknown assaults. So these author focuses on the deep learning architecture by combining the neural networks. So in order to complete the security solutions, the Liu and other authors focus on the different algorithms. So these next is the traditional approaches and advanced models. So first one is the event classification in the predictive systems. So in the event classification in the predictive system involved event categorizations, how the events are categorized. So it depends on the based on the patterns and features. So it derives from the different data, and this data is collected from the different resources, and traditional methods are used to categorize that particular events. So this statistical techniques is used in the machine learning models like rule-based system, statistical model, tree-based model, support vector machines, neural networks, KNN, and ensemble machine learning, where we can combine the different algorithms to check the accuracy of the different algorithms. Next is machine learning and AI models. In the machine learning and AI model, again, the different algorithm, decision tree, random forest, support vector machine, neural networks, clustering, anomaly detection, reinforcement learning. These different models these algorithms are used to check the accuracy with the different data sets. This is general diagram of the machine learning models. Now C is the feature engineering and optimization. In the feature engineering is very important in the predictive systems, where transforming the raw data into the actionable inputs. So first one is the feature extraction. Feature extraction uses the PCA, that is the personal this PCA reduces the dimensionality while retaining the key data variance. So LDA improves the class separability for the better classification. So feature selection is the method which is useful for the recursive feature eliminations, prioritize the impactful features, while tree-based models rank the feature importance. So regularizations using the L1 and L2 penalties remove the shrink irrelevant features and improving the model simplicity and generalization. So in the deep learning, we can use the autoencoders, which is useful for compress the data, extracting the latent features in complex data set like time series or image data sets. Evolutionary algorithm, genetic algorithm is which will be useful to optimize the feature subsets and enhancing the model accuracy. So this is the Red Panda architecture. In the Red Panda architecture, basically Red Panda is a real-time streaming platform which is useful for the low latency, fault tolerance, and scalable operations, which can handle the massive amount of data. So in single binary system, which eliminates the dependencies, like instead of using the zookeeper, it uses this Kafka handlers, and it uses the zero copy architectures, horizontal scalability, or fault tolerance system. So this real-time data streaming supports the predictive models with the immediate feature extractions and classifications, and it is used basically ideal for the fraud detections or attack detections in the IoT monitoring and predictive maintenance. So these are the key components of the Red Pandas architecture for the event classification. Log structured architecture. So it is Red Panda is designed around a log structured storage architecture. So meaning the data is written sequentially, allowing the fast ingestion and retrieval ideal for the real-time processing. So single threaded approach. Unlike the Kafka, which uses the zero copy architecture, so which does not require the buffer to store the data. So that is the one of the advantages of Red
The
Pandas.
7 minutes
So here,
reminder.
yeah, here in the single-threaded approach, unlike Kafka, which uses the multiple threads, Red Panda employs the single-threaded user interface, I/O models, and enhance the processing speed by reducing the context switching. So Raft consensus protocol is used in data compression and storage optimization. So in the enhancing the event classification accuracy through the feature integration. So improving the event classification accuracy and accomplished by the feature integration and ensuring that the features are continuously updated with the latest data, because in the real time number of devices are connected, and through that the will get the data through the sensors. So in the Red Panda optimized feature integration, Red Panda for data streaming. Data streaming is basically required when the real time data is collected, how that data is processed real time. So that's why we require this real Red Panda data streaming. So in the
Ma'am, I'm
producer and
sorry.
consumer, yeah,
Excuse
okay,
me, ma'am. We have crossed the time limit. Can you please
okay.
conclude the presentation?
Yeah, so these are the results. Now, conclusion. In this study, we have shown the Red Panda's incorporation in the predictive system. It improves the accuracy and dependability of the event categorization. Red Panda is basically useful for the real-time data analysis and fault tolerance design. It also reduces the latency, and in Red Panda enhance the overall performance of the event classification and event categorization. So this result is scalable and robust solution that is ideal for the dynamic situations like industrial IoTs. So it is useful for real-time predictive analytics, and empirical data shows using improved systems, robustness, and model precision. So these are the references. Thank you.
Thank you, ma'am. Are there any questions? Right. Since there are no questions, we'll be moving forward. Thank you so much,
Okay,
ma'am.
thank you.
Moving forward, I request Jayashree Palkar ma'am to kindly present a paper titled Exploring Technologies for Grave Disease Detection, a Comprehensive Survey. Do we have you here with us, ma'am? Jayashree ma'am, do we have you here with us? Do we have the co-author with us? Since the team is not present, I'll be moving forward. I request Suyash Karkhale to kindly present his paper titled Forecasting Food Demand in Supply Chains, a comprehensive comparison of regression models and deep learning approaches. Do we have you here with us, Suyash?
Actually, Suresh is not in meeting because having a technical issue. On behalf of him, I'm Pawan going to present the presentation.
Right. Sure, no worries. I'll stop presenting so that you can share your screen.
Okay, thank you.
Yes, your screen is visible.
Okay, just a second. I'm going to make it in full screen.
Yeah.
Yep.
Yes, it's
Hi
visible.
everyone. Hi everyone. Good afternoon. I'm Pawan Malik. Uh, I will be presenting our research paper on forecasting food demand in supply chains, a comprehensive comparison of regression models and deep learning approaches. These are the co-authors. The contents like abstract, objective, introduction, and these all added in my. Okay, let's take a look at abstract. The accurate food demand forecasting is very crucial in supply chains. It helps to minimize waste, reduce cost, and ensures product availability. Our study compares various regression models and deep learning technique to predict food demand more effectively. We analyze factors like price fluctuations and consumer behavior using different methods like gradient boosting, XBoost, CatBoost, and neural networks methods like LSTM and PyLSTM. To measure accuracy, we use standard evaluation matrix, which includes RMSE, which is a root means square error, MAE, mean absolute error, mean absolute percentage error, MEP. The key findings in our paper like CatBoost achieve the best performance among regression models, LSTM outperform other deep learning models in handling time series data, and also the advanced forecasting techniques like optimize decision making and improve operational efficiency. And also this paper contributes to enhancing sustainability in food supply chain management. Let's move to the objectives. Here are some objectives like develop accurate food demand prediction models, compare traditional regression models, sorry, methods with deep learning technique. Third one is like analyze key factors which can affecting food demand like price fluctuation, consumer behavior, and seasonality. And the fourth one is evaluate models using RMSC, MAP, and also improve decision making and operational efficiency in food supply chains. Introduction. So, why is demand forecasting important? Forecasting food demand is very critical in managing food supply chains, which affects consumer behavior, and making accurate prediction is very essential to avoid shortage and excess inventory. Some challenges in food demand forecasting are like limited storage capacity, requires demand estimation, seasonal trends, and regional preferences, which consumes more food. And the third one is like market fluctuations, which affect supply and demand unpredictability. And some of the limitations in traditional methods, which we observe, like simple technique like moving averages and linear regression fail to capture nonlinear trends. These models struggle with like high dimensional data and often lack to dynamic market conditions. So we move forward with the modern approaches like to address these challenges. Our study compares advanced machine learning models like gradient boosting, XBoost, LSTM, which can handle large data sets and complex dependencies. Let's take a look at literature survey. So several papers and studies highlighted here shows the importance of machine learning and deep learning in demand forecasting. The regression-based forecasting, like traditional time series models, have been used in past studies, but they are struggle with non-linear patterns. And the second thing is unassembled learning models like gradient boosting and XBoost, which improves prediction accuracy by combining multiple weak learners. And the third one we can see in literature survey like key findings like deep learning in forecasting, LSTM, which is long short-term memory, are highly effective. We have studied in literature survey. So moving forward, uh, methodology we used in our research, like the first one is data collection. We collected historical weekly sales data, which includes meal attributes, having uh, types, price, discounts, and the second data set is fulfillment center data, which is having location, services area, urban classifications, and all. The second step is data pre-processing. We finds the QNSs in numerical features using quantile transformation, then encoded the categorical variables using label encoding, and then remove the outliers. The third step was in our methodology is model selection. So we compare two categories of models. Like first one is regression models, and second one is deep learning models. As I told before, the regression models include gradient boosting, XGBoost, CatBoost, random forest, and light GPM. And deep learning includes LSTM and PyLSTM. The fourth process was evaluation matrix. So we use evaluation matrix to compare these algorithms like RMSE, MEE, MEP, and for implementation we use Panda, TensorFlow, and scikit-learn for regression models. Moving forward, so the result. So our evaluation reveals which model perform best for food demand forecasting. So the regression model which are performed best in regression like CatBoost, which achieve the best accuracy among the regression model. And the second one is gradient boosting and XGBoost also perform well, but had slightly higher errors. And in talking about deep learning models, LSTM outperform and BiLSTM and other models. And also it effectively capture long-term dependencies in time series data. The final outcome is that CatBoost and LSTM are the most robust solution for food demand forecasting. These models help to reduce waste, improve efficiency, and also to uh, optimize supply chain decision making. Moving forward, so these are the results and the values we have took after evaluation. Here we can see the CatBoost have with the
The
standard deviation
7 minute
value.
reminder.
Okay, MSC may have less value like 2031, which is best perform. Also, I have put these values in this matrix to we can see the CatBoost in first matrix CatBoost having the best accuracy. Also, you can take a look at the LSTM and PyLSTM model. The final conclusion: accurate food demand forecasting is very essential for like meal delivery services and inventory management. So our study identified that the CatBoost has the best regression model and LSTM has the most accurate deep learning approaches. So there are like limitation and future works we can conclude from this, like lack of holidays and event-based factors, which can uh, be in data set. Like the future work should be include external variables like holidays, festivals, and promotions. Yeah, that's thank you.
Thank you, Pawan. Are there any questions? Are there any questions?
Okay, thank you, Prince.
Thank you, Pawan. Moving forward, I would like to invite Hema Anjali to kindly present her paper titled Forecasting Health Insurance Expenses Using Machine Learning. Do we have you here with us, Hema?
Yes, ma'am.
Right. You can now present your screen.
Am I visible? Like my
Yes, your
PPT?
screen is visible. You may start.
Good afternoon, everyone. I'm Himanjali. I'm from Kerala University, Hyderabad. My paper ID is 577. I'm here to present my paper Forecasting Health Insurance Expenses Using Machine Learning. So, the main motive of our model is to predict health insurance cost prices for any individuals or patients. Accurate modeling is a key in health insurance or insurance based company to predict the fair prices and attract the customers. Based after the COVID-19 pandemic, individuals are searching for the insurance, which increased their need for accurate insurance estimations. There were many models like this before, but they have used like three regression models like SPM, linear regression, and random forest. But we can see that they were mostly dependent on handcrafted features. And if we are using deep learning methods, we require very large data set which can which needed high computational power, and real-time implementations might be expensive. Hence, we can also observe that limited effectiveness against complex dataset can also occur. So the datasets which we are using are we have 138 entities with key attributes, and the features we are highlighting are age, BMI, number of children, smoking status, regions, and gender. And then we are also performing exploratory data analysis, which relieves the uh, relieve reveal the correlations between age, BMI, smoking status, that is features, and the insurance charges. And these are the models we proposed in our project, like linear regression, support vector machines, gradient boosting, random forest, and XGBoosting. Linear regression is used to build a linear relationship between input features and insurance cost. It is very easy to implement. And comes to support vector machines, it classifies the data by finding the optimal hyperplane and maximize the class separations. And it can perform on linear data very easily. The gradient boosting. In gradient boostings, we are implementing ensemble learning techniques that builds model sequentiality. Hence, it can rectify these errors from the previous mistakes and can improve the model's accuracy. Random forest. As we know, the random forests combine multiple decision trees to improve the accuracy and reduce overfitting. And we can also observe that random forest works perfectly according to the previous models which were implemented by the very uh, previous papers. Next is XGBoosting. XGBoosting is a high efficient gradient boosting model that optimizes in performance by reducing the bias and variance. It reduces the overfitting, which we can say that it overperforms remaining all the models. So this is the methodology we are using. First, we're collecting the data. First, we are data collections, and then exploratory data analysis. Exploratory data analysis tells us the influence of the features, how it changes the cost or charges. Then after every data collection, there must be data cleansing or data pre-processing. We are performing pre-processing. In this pre-processing, we mainly will focus on essential processes like loss of information, management of categorical features, and normalization of continuous data. Then we'll go for data splitting. As we know, data splitting will be done in the 80 is to 20 ratio, where 80% is for training and validation and 20% is for testing. After that, we'll start with the model selection. We'll run all the models and we'll select the perfect and accurate model, and then we'll go for the model training. After the model training, we'll go for the hyperparameter tuning. Here, we are using hyperparameter tuning for like regularization L1 and L2 and cross validation process. And then next we are focusing on model evaluation. Model evaluation is a process where you performance matrices, and we're using mean absolute error, RMSE, and R square. Identify smoking, BMI, and age as the key predictors for this model evaluation. And then we'll come up with the cost. Now we can see the results. After this all data optimization and the processes, we can see that the gradient boost mechanism and XGBoost gives us the highest accuracy. As we can see in both of them, XGBoost gives us the highest accuracy because XGBoost models produce the highest accuracy because it can prevent overfitting using L1 and L2 regularization, and it can also work well with the non-linear variables like age, BMI, smoking status. And it can also capture complex relationship in data. And one more special feature of the XGBoosting is it can work well with the missing values. Fortunately, in our data sets, there are no missing values, but even if any missing values will be there, the XGBoost can easily handle it. And for the conclusions, we can see that XGBoost achieves highest accuracy because it overcomes all the models and it can perform well in a complex data set, and it can performing overfit well. And the feature importance, and we can see that each and every feature plays a crucial role in predicting the cost. Hence, we can say the feature importance is also very important, and scalability potential. We can see even if we increase the large data set, we can go for the large accuracy. The more the data says, the more accuracy you can see. The future enhancement, incorporating more real-time data and advanced AI techniques can further improve accuracy and comparability. Even we can see the future score is many insurance companies can take over the model and can predict the cost fairly and can easily attract the customers. Or and when a particular individual can easily predict its future insurance costs, even that is very much future scope of this model, and we are using explainable AI for being transparency and interpretability. Thank you.
Thank you, Himanjali. Are there any questions? Are there any questions? Since there are no more questions, we'll be moving forward. I request Shrikant Bopale to kindly present his paper titled Machine Learning for Cardiovascular Disease Prediction, a comparative analysis of models. Sir, do we have you with us?
Yes, ma'am.
Shrikant, sir, do we have you with us?
Yes, ma'am. Am I audible?
Yes, you are audible. I have stopped sharing the screen, so you can present yours.
It is visible.
Yes, sir, the screen is visible. You may start presenting.
Okay. Thank you. Today I'm going to present the topic as machine learning for cardiovascular disease predictions, a comparative analysis of all the models. Myself, Dr. Srikant Bhope, and my colleagues are Dr. Tarsin Mullah, Dr. Madhav Savanki, Sagar Kumar Dange, Sagar Patel, and Rohit Rao. So nowadays, cardiovascular disease is a widely prevalent, imposing international health issue with well-being for the effect on the individual world persons. So it contains the multi-factors analysis of including lifestyle of choices arises from the complex impact of the risk factors, unhealthy diets, and lifestyle of the individual in the real-time system. So this study regarding the various machine learning model you can use for the prediction system for the cardiovascular disease, also known as CVD. So this object of this is regarding how to compare the machine learning models, and we evaluate the machine models and identify the which is the best suitable for the early diagnosis of the CVD. Which machine learning models include random forest linear regressions, decision trees, neo-Bayes. These are the various models. So literature review, most of the researchers are focused on the linear regressions, support vector machines, random forest, and neo-Bayes and decision. So most of the first is regarding the RF models, which having the 94.51 accuracy. Second, author is use linear regression as a model, which having the accuracy as 90%. And third is use models as support vector machines, decision tree, random forest, and neo-Bayes. So which having achieved as 85% as a random forest model. And these are the some techniques used for the identify the and early detection for the CVD. So these are the models we are going to use in this particular study: logistic regressions, support vector machines, decision tree, random forest, and XGBoost. So most of the models are classification-based models, which having some identify and classify the issues from the various stages and provide the accurate predictions. So For this, we are using the clay-based heart disease dataset, which contains clinical and non-clinical diagnostic data, which includes the age, gender, chest pain time, blood pressures, and blood sugar related data, which having multiple features, and we can use that feature for the prediction for the CVD. And the models contains these are the accuracy measures, which contains accuracy, precision, recalls, and F measures. Accuracy is for overall correctness of the models, which having the true positive, and we are checking the true negatives. Then precision also is provide the proportion for the true positive prediction among the all positive predictions. Recall is proportion for the accurate positive cases and correctly identified. F measure is the hallmark means for the precision recall. So the results, we apply the most of the models like the linear regression, neo-based support vector system, ANN, decision tree, random forest, and XGBoost. So XGBoost having the more accuracy as 98.4%. Same is precision also, we got 98.57 as most of the XGBoost having the highest precisions. Recall also we got highest value for the XGBoost. And also F measure we got 98.32 for the XGBoost also. So conclusion is that most of the machine learning models for use for the prediction system, but XGBoost having the most robust model for the best performance, and which having the multiple combinations and provide the good and accurate results.
I'm sorry, Shrikant, your slides are not changing. It's stuck on 6th slide. Hello?
Hello, it's now changing or no?
No, it's on 6th slide. Right, I can see the data set used slide.
Yeah.
You may proceed from there.
So this is the result regarding which having the XGBoost having the most of the values as prediction results. These are the comparison regarding precisions. Here also we got XGBoost as a 98.57% accuracy. For the recall also we got XGBoost as 98.33% accuracy. And for the F measure also we got 98.32 for the XGBoost one. So machine learning models are highly effective for the predicting the CVD. We analysis that XGBoost having the robust for the best performance model for the prediction of SVD. In the future, we are going for the larger data set which had having the advanced features, selections, and reassembly techniques for the better predictions model. Thank you.
Thank you, Shrikant sir. Are there any questions? Are there any questions? Right, since there are no more questions, we'll be moving forward. I would like to invite Yathin Reddy to kindly present his paper titled Photovoltaic Cell Power Forecasting Using LSTM with XAI Integration. Do we have you here with us, Yathin?
Yes, I'm present.
Right, I'll stop presenting so that you can share your screen.
I hope everyone can see my screen.
Yes, I can.
Yeah, good afternoon to our esteemed session chair, moderators, and everyone else present here. Today I'm going to be presenting my paper, Photovoltaics will Power Forecasting using LSTM with XAI integration. That was completed with help from our project guide, Dr. P. Saranya. So what is this paper about? In this paper, we'll be implementing a deep learning model for photovoltaic power forecasting using something called global horizontal irradiance values. Global horizontal irradiance values are defined as the amount of solar radiation received on a horizontal surface at any given period of time. The amount of output a solar panel produces is mainly determined by these GHI values. So we will be implementing a long short-term network model and combining it with explainable AI techniques to improve the interpretability and to explain the predictions of the deep learning model across various forecasting horizons. So for our paper, we are going to be forecasting with 4 windows, specifically 15 minutes, 30, 45, and 1 hour ahead. So we're going to be forecasting for 4 windows in the future. So with the introduction in recent years, climate and weather-related events have become more frequent and more intense. And this is mainly a consequence of greenhouse gas emissions and other climate-related problems. As a result, there has been a pressing need to transition to renewable energy sources to combat this problem. Solar power is the most attractive and reliable option we have to transition towards renewable energy sources. Hence, to ease in the integration of solar power and to enable its adoption more worldwide, accurate forecasting is required to ensure that solar power stations can produce solar power reliably. Most research into solar power forecasting makes use of traditional machine learning models such as linear regression, XGBoost, SVMs, etc. Furthermore, there's no explanation into the decision-making process of the model and how the model reaches their predictions. So what is an LSTM network and why are we going to be using it here? An LSTM network is a subset of what is called a recurrent neural network architecture, RNNs. LSTMs they were invented to solve a problem of RNNs called vanishing gradient problem. So the diagram above shows the architecture of an LSTM cell where it has 3 gates, namely for get, input, and output gates, and it determines what sort of information from each time step is passed on to the next time step. So the main advantage that's provided by LSTMs is that they are useful in modeling sequential data such as time series, which is the case for this problem we've chosen. Another advantage by them is they can capture longer term dependencies over longer periods of time, and they can also model multivariate data sets, which is also the case here as we have multiple variables. So why incorporate XAI? The traditional machine learning models and deep learning models, their decision-making processes are not clearly understood. They're sort of viewed as black box models whose inner workings are not understood by humans. This black box nature of AI models is often the biggest hindrance in their application in critical scenarios. Explainable AI encompasses the set of techniques and methods used to make the decision-making process of these AI models more understandable to humans, thereby increasing trust in them, especially to non-technical users and other stakeholders. So the data set is taken from this paper, which contains the GHI values measured every 10 seconds in the specified time period. The dataset contains a total of more than 17 million measurements. This large datasets enables the training of more accurate models. However, the dataset first needs to be clean and polished properly. So the research objectives of the paper are presented as follows. The main objectives to develop an accurate forecasting model using LSTMs and to enhance model transparency and interpretability through XAI. Then we'll be evaluating the forecasting performance of the LSTM model and comparing it with benchmark reference models to see how well the LSTM model performs. Then we'll be creating graphs to understand the decision-making processes and what variables actually impact how much solar power is produced by a PV panel. Furthermore, we'll be using the Sharp library to generate the graphs and prove that it can be used for time series forecasting. So the justification of project sustainable development goals is as follows. It satisfies the following buckets of SDG. The first is affordable and clean energy. The second is industry innovation and infrastructure. The third is climate action. Fourth is sustainable cities and communities. And fifth is responsible consumption and production. So this is the proposed architecture. I'll be explaining each of the steps in the following slides. So first we have to clean the extensive data set we have, and this is the following steps we perform to clean the data. We remove the missing values, consecutive missing values, and then we create new data points using interpolation of the previous and following values. We remove any outlier values as they might affect model predictions. Next, we introduce another feature called Clear Sky GHI, which is a measure of the solar irradiance in clear sky conditions. And then we remove night measurements as no solar power hits the panels at night. This is done to remove bias in the model. Next, we calculate another component called Clear Sky Index, which is the ratio between GHI and Clear Sky GHI. Next, we downsample the data according to our forecasting windows. So for each forecasting window, we downsample it accordingly. The next module is the reference model we use, which is called the random walk and naive forecast model. This model estimates the solar irradiance at each time step as the current time step value plus some random forecasting error as mentioned by these formulas here. So this is a result of the forecasting model where the R square score decreases as we go from the 15-minute to 1 hour ahead windows. The R square score is a measure of how well the model fits the given data. So our model architecture will be that we'll be using an LSTM network with 3 layers consisting of 64 nodes each. And the final LSTM layer is followed by a dense layer, which aggregates the learned information, projects it into a forecasted value. We'll be using the TensorFlow and Keras library to implement the following. We also perform polynomial feature augmentation to introduce more features into the dataset. And we use a sliding window approach to incorporate time lags to produce better forecasts for both short-term and longer-term intervals. We evaluate the model using the following metrics. So the results of the LSTM model are described in this table. And as we can see, the R-square score is quite high for 15 minutes and gradually decreases to 0.4 in the 1 hour mark, meaning it performs well in shorter time forecasts and it decreases gradually. So finally, we implement XI using the SHARP library, which explains the output of any machine learning model. It is based from game theory. SHARP is a perturbation-based model, meaning it identifies how much each feature affects the output directly. So the results from SHARP were visualized using bar charts and B-form plots to better understand how each variable affects the prediction. So these are the B-swarm plots for each forecasting window. The y-axis represents the input features for each time step, and the x-axis represents the sharp value. The sharp value represents the impact on the forecast. So the positive sharp value means a higher GHI forecast, and a negative sharp value means a lower GHI forecast. So this is the B-swarm plots for 30 minutes ahead and 1 hour ahead. As an alternative to the B-swarm plots, we have also created bar plots, which represent which feature has the most significant impact on the output of the model. So the conclusion is we have successfully demonstrated that LSTM models can be used for solar power prediction, and we have incorporated XAI to understand the predictions and forecasts of the model. The model captures the long-term dependencies between the different variables. So the LSTM model is comparable to the benchmark model in the 15, 30, and 45-minute ahead windows, but it's performs significantly worse in the 1 hour ahead window. So the future work could be using a different data set that includes more climate and weather related data, or changing the architecture of the LSTM network to achieve better accuracy. So these are the references.
Thank you so much, Yatu. And with that, we conclude the presentations of the day. Are there any questions for the last presentation?
Hello, ma'am. This is Jayashree Palkar.
Yes,
I
ma'am.
lost my network. At that time, you called me. Sorry for that.
Okay.
573. ID number 573.
Yes, ma'am. Just give me a second. All right. Okay. Sherman, you can present your paper titled Exploring Technologies for Grave Disease Detection, a comprehensive
Yes.
survey. Right. Yes,
Yes.
I'll stop sharing so that you can share your screen.
Yes, yes. Is it visible, ma'am?
Yes, ma'am, it's visible.
Yes. So, good afternoon, everyone. Myself, Jayashree Dipalkar. Today, I am going to give the presentation on exploring the technologies for the grave disease detection. Okay, so this presentation explore the use of different types of technology for detecting the grave diseases, a critical issue for the global food supply. So now the importance of this grave disease detection is what? The identification of grave disease enables the prompt action, minimizing the crop damage and also the economic losses. This proposed study advances the precision agriculture techniques by encouraging the sustainability and environmental stability in the grape farming. So now these are the some challenges in the grape disease detection. So first one is the inaccurate diagnosis, then the costly solution and the image quality. So inaccurate diagnosis, in that misdiagnosis can lead to the inaccurate treatments, further the reducing the profit. That's like that. The currently computer-based solution can be expensive and difficult to operate. That's why this costly solution is also difficult. So now there are the two main methods using that we can detect the disease. So traditional method and a technical method. So in the manual inspection, what happened? The farmer traditionally relied on the visual inspection for the signs of disease, which can be time consuming and the subjective. And many times what happened, if farmers see that the according to that we can't detect the disease also. And then pesticide spraying. So pesticide spraying is often used to preventing the major but can harmful to the environment and the human health also. That's why this is the traditional method of grave disease detection. It's very harmful to the human. Now emerging technologies for the grave disease detection. So these are the some trending technologies which is used for the grave disease detection. So machine learning, deep learning, and Internet of Things. So in the machine learning, algorithms like SVM and ANN can analyze the images and identify the disease pattern. Here also the CNN, RNN technologies or algorithms also used. In the deep learning, also such as the CNN, and can learn complex features from the image and accurate disease detection. And in the IoT, sensors and wireless communication can collect the real-time data on environmental conditions and plant health. So according to this, we can get the result. So now this is the literature survey. So like our title, this is the survey for the different types of technologies which are used for the detection. So according to this survey, we can say that there are the different types of approaches are used, and according to that approaches, different types of database, and we can see the results also. We will get different types. Only one thing is another in this literature review, all the results which is in the training model, rarely results shows in the testing model. So these are all the result is related in the training model in latest technology. So now deep learning for the grave disease detection. This is the flow of the grave disease detection. First, we have to collect or gather the all data set, including the healthy and disease plants. Then model, we have to train the model. If we use the deep learning model, so in that we have to train on the data set to learn the pattern and features associated with the different diseases. Then we have to evaluate that model using the separate data under the testing category. And again we have to deploy this. So this is the block diagram, common block diagram of research methodology. So this shows the grip lived data set, which includes all type of diseases and healthy live. Then we have to pre-process that data according to their category, and then fine-tuned as a transfer learning pre-trained model and fully connected layer, and after we will get the result which is in the form of disease or healthy leaf. So now benefits of deep learning for this grave disease detection is we have to improve accuracy, and again we detect that disease in the early stage, and again, the third one is the reduce the cost. So improve accuracy means what? The deep learning models can achieve the high accuracy in the disease detection, reducing the misdiagnosis and improving the treatment effectiveness. If we compare this deep learning method with the manual inspection, so definitely it will give the more accuracy related to this. And again, the early detection allows for the timely intervention, minimizing the spread of disease and maximize the crop yield. So, if we get the detection early, in that case, we can stop the spreading of that disease. Then, reduced cost, the automated disease detection can reduce the need for the manual inspection and expensive treatment. So, these are the benefits of this deep learning for grave disease detection. Then the future directions in the grave disease detections are advanced AI model, then real-time monitoring, data integration, and precision agriculture. So future research will focus on the developing even more sophisticated AI models, integrating data from the various sources, and the implementing precision agriculture techniques for the optimal grave disease management. So we can, if we think about our literature survey, so in that there are different types of author which work on the separate AI model, and if we take the hybrid combination of any model, then definitely we will get the more effective result. And these are the references which I used for this survey. Thank you so much.
Thank you, ma'am. Thank you for the presentation.
Thank you
Are there
so
any
much.
questions? Since there are no more questions, I'll conclude the session with the presentation. Thank you everyone for the insightful contributions from all of your sides. Before we move forward to our closing remarks, I'd like to invite Dr. Lokendra Singh Umrao to share his thoughts about today's session. So,
Good,
yes.
yeah. Good afternoon, everyone. It is with immense gratitude that I stand in this conference to express my sincere thanks to each and everyone. All the presenters have presenting their papers in very well mode, and the technical team have the very much efficient work. The commitment to excellence and what truly make it this event is special. Thank you for all making this day and conference memorable, and let us continue to strive for greater higher thoughts and new spirits, being by acknowledging the presence of all the faculties, students, and staff members. It is my continue learning and working together to achieve future goals in the near futures. Thank you. Thank you very much.
Thank you so much, sir. I sincerely thank all our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for all of you. We, on behalf of the whole team, thank you for the support during this 9th version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days. Further, All the papers have already been forwarded to this printer. The publication will be live within 6 months. Kindly cooperate with the team of SmartCom 2025. I also thank our session chair, Dr. Lokendra Singh Umrao sir, for chairing this session and has just a small token of appreciation from the team of SmartCom and Global Knowledge Research Foundation, sir, for your efforts. Thank you for your valuable presence to all the attendees and to sir. I request everyone to switch on their cameras for a quick snapshot for the virtual conference. Yes. Okay. 1, 2, 3. Thank you so much, everyone. Have a nice day.
Thank you.
Thank you.